Okay, let's unpack this. What if we told you that the future of military technology, everything from quantum networks to AI right at the tactical edge, isn't some distant idea? It's actually being meticulously planned right now, often behind the scenes, through incredibly detailed documents. Today, we're taking a deep dive into one of those blueprints. An actual U.S. Army document, it's called a Performance Work Statement, or PWS. This one outlines the cutting-edge scientific and engineering support needed for the Army Research Laboratory, ARL, and it's labeled CUI, Controlled Unclassified Information. So sensitive, but not top secret. It gives us a really fascinating, almost unprecedented look into the specific R&D efforts aimed at giving soldiers that critical tech advantage.
Right. And what's really illuminating here, you see, is that this document isn't just some dry list of requirements. It's basically a living blueprint for the innovation, the R&D, that underpins the Army's core capabilities. Things like command, control, communications, computers, combat systems, intelligence, surveillance, and reconnaissance C5ISR, as it's often called. So this deep dive, it'll really show you the immense scope of work involved, all controlled by the U.S. Army and ARL, and how that fundamental research translates into, well, tangible advancements for what they call knowledge superiority. It's really about being smarter, faster, more informed than any adversary out there.
So if we strip it down then, what's the core mission of ARL as laid out here, particularly for their Army Research Directorate, the ARD? What's the big picture?
Well, at its heart, ARL's mission is to make sure U.S. soldiers always have that technological edge. Always. They do this through a really broad multidisciplinary program. Basic research, applied research, exploratory development analysis, the whole gamut. The ARD specifically, it zeroes in on the scientific research in really crucial fields. Information processing, network sciences, communications, info assurance, battlespace environments, computational sciences, advanced computing. It all funnels towards one goal: creating, exploiting, and harvesting innovative tech to enable that knowledge superiority for the warfighter, across every single part of U.S. Army operations, making sure forces operate with the best information possible.
That sounds incredibly foundational, just vast. To achieve something that comprehensive, what kind of services and solutions are we actually talking about? What are the practical pillars supporting all this?
It covers the full spectrum, really, from the initial R&D stages all the way through T&E testing and evaluation, and then getting those results out there. Dissemination. It also extends to very specific high-level infrastructure stuff, like supporting the High-Performance Computing Modernization Program, the HPCMP, that manages the supercomputers, and even managing the Defense Research and Engineering Network, DREN, and its classified counterpart, SDREN. Think of it like providing the high-octane fuel and the specialized highways for all this cutting-edge research to actually happen.
Okay, here's where it gets really interesting, especially if you're curious about how these huge government research projects are structured. This document outlines creating a multiple award indefinite delivery indefinite quantity contract vehicle, an IDIQ. For those of us maybe less familiar with government contracting lingo, what's the objective behind this? What kind of services are these individual task orders, TOs, supposed to cover?
Right, so imagine it like a master agreement, or maybe a pre-approved shopping list for highly specialized, really cutting-edge services. Instead of starting from scratch with a new contract, every single time a new research need pops up, this IDIQ vehicle lets the Army Research Director quickly issue these individual task orders. And that structure is brilliant because it gives them immense flexibility. Huge flexibility. It means they can rapidly bring in expertise in things like advanced computer science research, engineering R&D, network security operations, cyber defense, integrating new network tech. It just streamlines the whole process for a massive array of highly technical, often urgent military R&D efforts. It's really built for agility, in a tech landscape that changes so fast.
And to tackle topics this advanced, I'm guessing the personnel requirements are pretty demanding, extremely demanding. What does the document emphasize about the kind of contractors and teams they need?
Oh, absolutely. We're not talking about just anyone showing up. The document is explicit.
They need highly technical, cutting-edge military R&D personnel. And the contractors, they're on the hook to ensure their employees aren't just qualified on day one, but get continuous developmental training. That's crucial, right? To keep their skills sharp, keep their knowledge current with the absolute latest advancements. Plus, each task order gets a dedicated contracting officer representative, a COR, and often technical monitors, too. That ensures the work stays on track and meets the Army's standards. It's about maintaining a consistently elite workforce.
Okay, beyond the direct research, there are these extensive support requirements mentioned. Let's start with program oversight and support. What does that involve for the contractor program manager? Why is that role so critical? Yeah, that's like the scaffolding, right? The
Hmm.
structure holding it all together. The program manager provides essential oversight for all the contract employees, the subcontractors too. They ensure not just a safe working environment, which is key, but also professional conduct and compliance across the board. They're the ones tracking costs, compiling those crucial monthly reports, handling all the complex admin details for purchasing, communications contracts, financial data submissions. Essentially, they make sure all the moving parts of these complex research programs are organized, accountable, and running smoothly, because without that meticulous oversight, even the most brilliant research could, well, lose its way.
And what about the day-to-day administrative and security support? It might sound routine, but you're saying this is the invisible framework that lets the sensitive research happen securely. What details stand out there?
You're spot on. This isn't just pushing paper, it's the essential gatekeeping that protects critical information. It includes processing visitors, vetting new contract hires, validating security clearances constantly, managing physical access badging, arranging escorts, handling all the complex travel requirements, both classified and unclassified visits. They also track updates in systems like JPS, that's the Joint Personnel Adjudication System, screen new hires, maintain a precise inventory of all government-furnished equipment. It's meticulous. Without this administrative and security backbone, the risk of compromise for these vital research efforts would be immense. It's non-negotiable.
Okay, shifting to more strategic aspects. The document details program and project management and analysis. How do contractors support the government's technical managers here, especially in making those high-level decisions?
Right, this moves beyond just tracking things. It's about providing strategic intelligence, strategic insights. Contractors support the overall planning, the execution, reporting, and continuous monitoring of these huge programs. This involves digging into data, consolidating it, presenting clear status reports, that's important, but maybe more importantly, identifying potential issues before they become big problems and providing actionable recommendations. And crucially, they also research other government agencies, universities, commercial partners, looking for potential collaborations, internal or external. It's about making sure resources are used effectively and guiding the overall program direction with data-driven insights. They're essentially helping the Army figure out where to invest next.
That leads to a really important question. In a field needing such specialized, forward-thinking talent, how does ARL make sure the next generation of scientists and engineers gets involved?
That's where educational outreach analysis comes in.
Hmm.
It's a cornerstone, actually. The contractor is responsible for building and coordinating a technology-focused education and outreach program. And this isn't passive stuff. They proactively seek out and implement outreach efforts. They participate in exchange meetings, promote HPC use within DoD. A really significant part is developing and managing a comprehensive summer outreach program, specifically for high school, undergrad, and graduate engineering and scientist students. They handle everything: recruiting, logistics, even identifying specific research projects for these students to work on. It's a direct investment in that future workforce, building the pipeline.
Okay, now let's get into the pure R&D, starting with high-performance networking research services. What's at the absolute forefront here? What breakthroughs are they chasing and how information flows?
Yeah, this section really shows the Army is pushing the boundaries of network capabilities hard. They're deeply invested in experimental development, testing advanced networking tech. So one key area is software-defined networking, SDN. Think of this as making networks incredibly smart, flexible, able to reconfigure themselves on the fly. They're researching how to model network performance for security, how different types of networks can work together, heterogeneous networks, and even designing the next generation of SDN setups, extending it to production networks. Then there's dynamic optical networking done. This is all about super fast, high-performance optical networks using light for data. They're looking at things like reconfigurable optical interconnects for supercloud computing, solving challenges in dynamic provisioning. They even support DARPA programs here. It gets into fundamental physics, new materials for laser tuning, sophisticated software for control planes, really deep stuff, and maybe the most futuristic bit, quantum networks. This isn't just theory on a blackboard. It's laying the groundwork for truly unhackable, instantly secure communications.
You're prototyping with quantum optics infrastructure, developing quantum-based frameworks for distributed computing, designing entirely new networks for future RDT&E research, development, test, and evaluation. Imagine a battlefield where your signals just cannot be jammed or intercepted. That's the kind of knowledge superiority this research aims for.
That is incredibly cutting edge. Wow. Okay, once that information flows, what about the raw processing power needed to make sense of it all? What kind of computational architectures research services are they pursuing? How are they building the brains behind these advanced systems?
Right, this delves into the very foundation of computing, how to make future military hardware incredibly powerful, but also efficient. So they're heavily into computing architectures research. Investigating emerging traditional systems, yes, but also truly novel ones, like quantum systems and even neurosynaptic systems inspired by the human brain. This involves rigorous benchmarking, developing models to predict performance, optimizing algorithms, creating parallel software for these complex systems. It's about squeezing every last bit of performance out of the hardware,
Right.
even getting into specialized compilers and programming languages. Then there's advanced computing at the tactical edge. This is critical, getting serious compute power and AML capabilities into constrained environments right where the soldiers are operating. Think about enabling task migration among friendly assets, assessing battlefield computational entities, developing new ways to emulate these tactical environments. It's all about maximizing computing capacity, developing incredibly optimized AI algorithms that can run on limited power, often using Python, C++ in an HPC environment. They're also researching scalable technologies for spatial and temporal data analytics and machine learning, basically developing new ways for AI to learn from truly massive, high-dimensional data sets to discover useful info in real time. This covers accelerated parallel approaches, developing new ML models, exploring novel big data techniques, data mining, genetic algorithms, signal processing. It's like teaching a super smart detective to spot patterns in millions of clues incredibly fast. And finally, there's the essential high-performance computing technology hardware and software support. For the HPC Center itself, installing, maintaining these supercomputers, configuring software, managing access, developing system tools, the whole 9 yards.
So after the hardware, what does this all mean for the fundamental scientific challenges? What kind of computational sciences research is outlined to really push the boundaries of simulation and analysis?
This area is all about building incredibly realistic digital twins and predictive models. For complex military scenarios, they're focused on extreme scale and multi-scale computational frameworks, aiming to lead in coupled simulations, predictive modeling for complex physical systems. Imagine developing new parallel solvers, advanced post-processing algorithms, physics-based code, applying state-of-the-art machine learning to tough Army problems. This also includes porting code to run on powerful GPUs, creating new artificial reasoning models, even developing mixed reality environments for training and analysis. It's almost like they're trying to build a digital replica of the entire battlefield, predicting everything from weather effects to cyber attacks. They're also developing interdisciplinary computing methods, which means coupling different physics models, real-world phenomena to understand complex systems better. This includes network simulation, emulation, software development to predict hardware performance based on variables like terrain, weather, network traffic, and dynamic environments. And then there's overall computational science support. That covers basic and applied research for critical Army needs: AML, autonomy, algorithm optimization, edge computing, novel computing architectures, the full software R&D lifecycle. Lastly, simulation and emulation in HPC for large-scale tactical networks. This focuses specifically on communications modeling in contested environments. This is where they simulate things like electronic warfare, cyber effects, develop new radio waveforms, model the complex RF environment, all to make sure communications can survive and thrive even when things get really tough.
That's a massive leap in predictive power. Okay, let's shift gears to information sciences. How does this document highlight the Army's efforts in managing and, more importantly, leveraging just vast amounts of data for real-time decision-making?
Yeah, this section is absolutely crucial because it's all about making sense of that overwhelming flood of data you get on a modern battlefield. It reinforces themes we've touched on, like software-defined networking and working with high-dimensional data-scalable data sets. Especially when data is limited or uncertain, they're doing intense data analysis and simulations for predictive analysis, developing novel machine learning techniques, finding solutions to detect specific objects of interest, even in compromised or limited data. There's also a focus on online support software tools, identifying, designing, implementing accessible online tools for program management, real-time data sharing, robust developer environments for HPC. A major thrust is in common operating picture systems, cyber defense, and decision-making. This is huge. Developing methods for cyber-resistant information processing, creating cross-reality environments for command and control. Designing server network architectures to synchronize info from diverse sensors. It also includes researching metrics for decision efficacy, improving communication with edge devices in the field. How effective are the decisions being made? They're heavily invested in artificial reasoning and machine learning, researching causal discovery from time series data, developing interpretable causal models,
techniques for predicting rare but high-impact events. It's about teaching machines not just to recognize patterns, but to understand why things are happening, causality. And importantly, exploring autonomy and robotics, investigating multi-agent autonomous systems, robotic systems, developing coordination methods, creating techniques to assess and predict their behaviors. Perhaps most topical right now, significant work in generative AI, both theoretical and applied research into state-of-the-art models, creating new computational models for heterogeneous data, conducting experiments to see how these powerful new AI tools can actually be leveraged effectively and safely. Ultimately, the overall information science support builds the theoretical and modeling foundations for critical future areas, like the military Internet of Things, IoT, the Internet of Battlefield Things, IOVT, and that crucial intersection of robotics and autonomous systems, intelligent systems, smart sensors, especially for complex urban environments. It's all about creating a truly intelligent, connected, and resilient battlefield.
Wow, that level of interconnected research, it must require significant collaboration, a really robust infrastructure. What does enterprise environment support tell us about how ARL fosters innovation beyond just the pure R&D labs?
All right, this section is about creating the perfect ecosystem for that innovation to flourish. ARL wants to equip its premier lab with all the necessary resources, people, technology, streamlined processes to truly facilitate novel R&D. This involves deeply understanding user requirements, building compelling business cases for new initiatives, making formal recommendations on how best to share information and data with mission partners. Critically important, it's about actively fostering synergistic relationships with international allies, academic institutions, even entrepreneurial communities, bringing ideas in from everywhere. They're also focused on developing accessible online support software for program management, secure data sharing, a real-time developer environment with advanced search capabilities. And a key element is leading the architecture and deployment of a customized, flexible environment, designed specifically to incubate new technologies and seamlessly transfer that research knowledge out to the field where it's needed.
And for the most highly sensitive R&D, there's this mention of ARDANET support. What exactly is that? Why is it so crucial and specialized?
ARDANET. Think of it as a dedicated, completely segregated network. A sandbox, but a highly secure one. It's specifically for R&D activities that are simply too sensitive or specialized to run on standard production or enterprise networks. The contractors here are responsible for its entire lifecycle, designing it, engineering it, operating, administering, maintaining these isolated environments. This means extensive IT and information assurance, IA, functions. Everything from hardware setup, Linux virtual machine management, rigorous backups, patching, monitoring, developing stringent security policies. They ensure full compliance with ARL's specific IA requirements and manage user access from start to finish, onboarding, offboarding, the works. And they collaborate closely with ARL elements to maximize security while ensuring the integrity and capabilities needed for that groundbreaking RDT&E. It's the ultimate secure playground for top-tier sensitive research.
Okay, given all this context, let's zoom in a bit on network sciences research and network security research. What are the Army's top priorities in these, well, increasingly crucial areas of connectivity and defense?
Okay, for network sciences research, the priority is really theoretical research, building the fundamental foundations for the Army's future mission-critical requirements. This includes things like advanced mobile ad hoc networking manets for dynamic environments, ensuring the quality of information flowing through those networks, developing trust models for data, pushing the boundaries of quantum networking, like we mentioned. Also, communication in resource-constrained environments, evolving software-defined networking, understanding social networking dynamics, developing cognitive networking where networks can learn and adapt. It's about building the underlying principles, the science, for future battlefield comms. Network emulation, simulation, military IoT are also key here. It also involves software-hardware development for virtualized environments, data visualization, and machine learning applied to networks.
And network security, that sounds incredibly high stakes.
It absolutely is. For network security research, the stakes couldn't be higher. The contractor needs deep expertise in both defensive and offensive cybersecurity. You need to understand both sides. Plus, robust software development skills, tactical mission planning in cyberspace, applied mathematics, machine learning, data science, and comprehensive network and system administration. It's a broad skill set. They provide subject matter expertise to external customers across the whole system acquisition lifecycle. They conduct rigorous web application security assessments, enhance and secure production network technologies, and critically, ensure full compliance with the DoD Risk Management Framework Standards, RMF. It's about building networks that can withstand and even counter sophisticated cyber threats. Ensuring the integrity of all military operations depends on it.
Finally, with all this groundbreaking and frankly highly sensitive work, security is obviously paramount. The document details extensive security requirements for contractor personnel. What truly stands out to you in terms of the rigor, the depth involved?
The sheer depth of these security requirements really drives home the critical nature of the data and systems being protected. It's not just about technical skill. It's about a robust security posture woven into every single level, every person, every process. We're talking mandatory anti-terrorism level awareness training, thorough background checks just for installation access. Common Access Card, the CAC, issuance only after a favorably adjudicated background investigation. No exceptions. There's also IWA-TCH training that's about recognizing and reporting suspicious activity. Everyone's eyes and ears. Strict registration in Army training certification tracking systems just to get network access. They have to develop and implement comprehensive operations security, OPSEC programs and training, alongside stringent DoD and Army training and certification requirements for information assurance, IA, and IT functions. Specific certs are needed. For classified info, contractors must adhere to specific Federal Acquisition Regulation clauses, the FR clauses, and the National Industrial Security Program Operating Manual, the NISO-PIM. And even for CUI, Controlled and Classified Information, there's a mandate to comply with NIST 800-171. That might even require a system security plan and a detailed plan of action, a POA&M. This whole holistic approach, it highlights that security isn't an add-on, it's not an afterthought. It's woven into the very fabric of this entire research enterprise.
What a deep dive. Seriously. We've unpacked a document that, yeah, at first glance, might seem like just another government contract, but it truly lays out the immense, multifaceted mission of the U.S. Army Research Laboratory. From the absolute foundational science all the way to the tactical deployment of cutting-edge tech. It's just a fascinating look at the huge coordinated efforts to ensure our soldiers maintain that crucial technological edge.
Indeed. And this document serves as such a powerful reminder that knowledge superiority, it isn't just an abstract concept, right, or some buzzword. It's meticulously built on a vast ecosystem of interconnected research, cutting-edge development, and incredibly stringent security. The seamless integration you see here, high-performance computing, advanced networking, AI, emerging quantum tech, robust information security, all working towards enhancing warfighter capabilities. It's truly remarkable. It's really a testament to the foresight and the dedication involved in shaping the future of defense.
This makes me wonder, and maybe something for you, the listener, to think about too. How might the advancements detailed just in this one document things like generative AI for complex data analysis, or that advanced computing right at the tactical edge? How might they not only redefine military operations, but also, maybe inadvertently, accelerate the development of remarkably similar technologies for much broader civilian applications in the years to come? Food for thought.